Hello and welcome back to Pre-Calculus. This is a video over Unit 8 and we're going to be talking about graphing trigonometric functions. Okay, so in Section 1 we're going to be graphing the sine and cosine functions. So before we get into the graph of each of these, what I want to do is show you guys an animation. And so in this animation, what you have is you have a unit circle right here. And in that unit circle, what we'll see is we will see, here's your center, here's your point on the circle. What we're going to do is we're going to go around this circle and we're going to analyze sine. Now remember, we are analyzing the function y equals sine of x. Now, a couple different things here. First of all, x is your angle measure. Okay, and the y value, okay, when we think about the sine value, sine is the y value on the unit circle. So the y value that is going to be plotted is going to be the y value on the unit circle. Okay, so we're kind of doing a couple different things here. And so that's what we got to recognize, is that x is the angle measure, and what you'll see is that the x-axis here has different angle measures, and we have they're in radians. So we got pi, 2 pi, 3 pi, and 4 pi. Okay, so what I'm going to do is I'm going to play this animation. All right, so as this radius goes around the circle, we've got a couple different things that we can notice. Okay, number one is as this is moving across, that represents the angle measure. Okay, so let's start back at the origin. So here, 90 degrees at pi is where it lands, and it's over here. Okay, it's going to come back around and it's going to hit 2 pi rotations. Okay, and it's going to continue to do that, all right? And that's what we're doing, is we're animating this going around the circle. The x value, all right, of our sine function represents the angle measure, okay? Now, the other thing that I want to talk about is that what we're doing is, as we're going around, we have this wave. We call this a sine wave. And the y values are plotted from our sine wave based off of the y value on the unit circle. Okay, so, and that's what we're doing. Okay, and so I wanted you guys to see this animation, as I'm going through it. All right. Okay, so as we go back to our video, let's look at this graph here, because this is a better depiction as to what we were doing. So remember that here, the x values are the angle measures. Okay, and the y values here are the y values on the unit circle. Okay, so as we go through, we have all these different points. We have the point 0, 0. We have the point, pi over 2, 1. We have the point pi 0. You have the point 3 pi over 2, -1. And then you're back at the origin here at 2 pi, 0, okay? And what you want to think about is, some of the other values. Like if I were to find, say, pi over 4, okay? Remember that if we find, say, sine of pi over 4, that's the value square root of 2 over 2. Okay, so sine of pi over 4 is square root of 2 over 2. So that's this value here on my graph. okay, and that would be the square root of 2 over 2. You know, same thing with, you know, 3 pi over 4. You know, that y value would be square root of 2 over 2. So that's how we're generating these points, is by evaluating these trig functions, and those are the points that we get, okay? And that's how we get them. Now, the cool thing is that, you know, as we go through this, you know, all this will do is just repeat. And so you have this sine wave that goes forever and ever and ever, and that's what you got. All right, so now let's talk about the cosine function. But before I do the cosine function, let's look at an animation. Okay, so this is the same thing. Now what we're going to be doing is we're going to be talking about the function y equals cosine of x. So on this one, you know, same thing for the x value. The x value is your angle measure. Okay, and the y value of this function is created from the x value of the unit circle. Okay, so what I'm going to do is I'm going to play this animation. Okay, and so as this animation goes, what I'm going to do is talk about, you know, how as I go around the circle, you know, again, your x-axis is created by the angle measure on the unit circle. Now the graph is created strictly by the x values of your unit circle, okay? So, you know, as we do this, okay, and I've paused the video because I want to show you a couple things, okay? When your x, you know, as you start off at 0, the x value on your unit circle right here is 1. That's what we plot. When the angle measure is 0, we plot a value of 1, okay? When we go up to, you know, pi over 2, all right, your x value on the unit circle is 0, so therefore that's where we plot 0. When your value is negative pi, the x value is negative 1. That's why we plot a negative 1 at pi. Okay, at 3 pi over 2, we're back down at 0. Okay, and then at 2 pi, 1 revolution around, we're back at 1. Okay, and that's how we plot these points. Okay, so always remember and look back here that the x value is your unit, is the angle measure. The y value is created from the x value of the unit circle. So it is a little strange, but you know, all we're doing is we're writing this as a function, and they have specific values. Okay, so try not to get too confused about how we generate these. Remember, cosine is x, sine is y, and that's how we create those points. Okay, so again, you know, back here, let's write on our notes that the x is the angle measure, and that the y values of your cosine function are created from the x value of the unit circle. Okay, and you know, let's just, you know, come in here and plot some of these points that we have. All right, we've got 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2 comma 0, and then 2 pi is 1. So I'm going to come in here, I'm going to write 0, 1. I'm going to write pi over 2 comma 0. Okay, I've got pi comma negative 1. I've got 3 pi over 2 comma 0. And then here I've got 2 pi 0. Okay, and so, you know, I'm going to come over here, and you know, we could plot other points. We could plot like pi over 4, 3 pi over 4 if we wanted to. But I want to, you know, I'm going to come in here and I'm going to draw in a little unit circle. All right, so let me put my axes here. All right, and let's think about this. All right, you have, and I'm just going to draw these ones here. Okay, I've got 0, pi over 2, pi, 3 pi over 2, and then 2 pi. okay? And let's just, think about these points that we've got. At 0, you've got the point 1, comma 0. Okay, at pi over 2, you've got 0, 1. At pi, you've got negative 1, 0. At 3 pi over 2, you've got 0, negative 1. Okay, so realize that these are the points that I'm plotting here. Okay, these are the y values that I'm plotting on either of these functions. So remember, it's just tricky. Your x value on these functions comes from your angle measure as you go around the circle. And if we're graphing the sine function, which I'll highlight this in red, okay, the y values come from the y values on your unit circle. Okay, if we're talking about the cosine, color that in blue, the y values come from the x value of your unit circle. Okay, so now the cool thing is about this is that as you go around the circle, okay, these things are what we call periodic functions. Okay, and a period is the horizontal length of one cycle of periodic function. So what I want you to see here is that as if you start here at 0, 0, you have one cycle of this function, okay? And then it repeats itself, and you have a different cycle of that function. And so it's going to occur more than one time, okay? So a period is one cycle of the periodic function, so periodic function repeats, all right? And so that's the case for sine and cosine, okay? Both of these regular graphs have a period of 2 pi, okay? Meaning that if we just have this generic length here, all right, we're going to have this period of 2 pi, and then that will repeat, okay? So that happens for the sine function, and it also happens for your cosine function, okay? Where one cycle repeats after 2 pi. Okay, so the amplitude is this value for A, okay? Amplitude is half the distance between the maximum and the minimum values of a trigonometric function. So when we just have a regular sine function, and I'm going to color that in this orange color over here. This is the graph y equals sine of x, okay? Now we have to think about there is this multiplier of 1 in front of sine of x, okay? And when I have that, what that means is that from 0 going up, we have a maximum value of 1, okay? And what that means is that this graph will hover between 1 and negative 1. All right? So you have this point here at pi over 2 comma 1. And then you have this point way down here, 3 pi over 2 comma negative 1. All right? So what we can say about these graphs is that our y values are going to be between 0 and 1, or negative 1 and 1. Okay? And so my amplitude for a typical sine function is 1. All right, so for sine of x, our amplitude is equal to 1. All right, and that's going to be pretty standard for any trig function, okay? But over here in this blue function, when you have y equals 4 times sine of x, your amplitude is equal to 4. And the reason why is because, you start at 0, 0. Your largest value here is pi over 2 comma 4. Okay, and so we can start transforming these graphs. Now, what this means is, if we think about the unit circle here with amplitude, let's think about what we're doing. If we're going from 0 And as we rotate around that circle to pi over 2, we have a y value of 4. Let's think about what we're doing. You know, if you have a standard unit circle of radius 1, when you introduce this 4 into here, what you're really doing is you're changing the radius of the circle to 4, and you have a really big, and sorry I'm kind of drawing all over the place, but what you have is you're changing all of a sudden your radius to 4, okay? And that's essentially what you're doing there, okay? And that's that, okay? That's what you're doing, because when you have this, okay, 0, you know, y value of 0, if you change your radius to 4, all of a sudden you go to pi over 2, your y value is 4. And that's what you're doing when you're changing the amplitude. So all you're doing is you're making the circle bigger, okay, to give you that kind of perspective. All right, the next thing we have is a vertical translation. All right, so this is something where, you know, if you have this function, oops, you know, h of x is equal to f of x plus k, a vertical translation of f of x by k units. So what you're doing here, you have your general sine function, okay? And what you'd want to do is then shift everything up 3 units. So if you look at all the different points you have on this sine graph, you're just going up by 3 units, all right? And so that's pretty standard. That's something that we've seen quite a bit. But these are going up by 3 units each time, okay? All right, so let's practice. Let's take a look at one of these graphs, okay? And what this graph says is that we've got y equals 2.5 times sine of x and then plus 3. So what I'd want to do here is just look at my original sine function, okay? And we kind of just need to know these points here. But I'm going to graph y equals sine of x, okay? 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi is 0. So here are all of those different points, okay? Then what I want to do is my amplitude, all right? My amplitude is 2.5. So what that's going to do is that's going to stretch these points up, your maximum and minimums, to 2.5. Okay? And that's going to affect the graph that way. Okay? You're still going to have 0, 0. You're still going to have pi, and you're still going to have 2 pi. Okay? But the next thing I want to do is take all these points and translate them up 3 units. Okay? So instead of this being the point, you know, 0, 2.5, we're going to add 3 to that, and that's going to be, what is that, 5.5? All right. Taking negative, let's do this. This is the point of 3. 3, 3. Okay, so what I'm doing is I'm taking all these points that have a y value of 0 and I'm moving them up 3. I took this point right here, which is a value of 2.5, added 3 to that to get to 5.5. So I have this point here. Okay, and then if I take negative 2.5 and add 3, this is just going to give me 0.5 here. So what I have is I have this new graph. All right, and let's talk about what I just did. Here's my normal sine function, okay? I increased my amplitude to 2.5, okay? Here and then here, okay? So I stretched it out. And then what I did is I translated this graph up 3 units. So each one of these points went up 3 units on the graph. Okay, so now let's check out our points that we had. All right, so now I've got the point 0. So this is the point 0, 3. This is the point pi over 2, comma 5.5. This is the point pi, comma 3. This is the point 3 pi over 2, running out of room here, comma 0.5. And then this point right here is the point 2 pi, comma 3. Okay. All right, so that's all we're doing for this video. Hopefully all this makes sense. It's some brand new stuff for you. Hopefully you enjoyed it, and we'll talk to you soon. See you later. Bye.